Hello everyone. We're going to go over the requirements for Project 1, going over the business rules and any other details of the project requirements, also indicating how the business rules will translate into an ERD, an entity relationship diagram, also what's known as an entity relational model. From there, we're actually going to implement that model, meaning that we're going to take the diagram and then forward engineer it to a live MySQL DBMS where the data will reside on a remote server, our CCI server. Let's begin. As an IT director for financial accountants, your team was asked to create an online family finance database for clients who will record credits, that is income, as well as debits or expenses, in order to keep track of monthly, yearly budgets. The following categories should be included as examples of income and expenses. There are 19 of them. I'm not going to go through all of them there, but you can read these here. And then debits or expenses, 15 generic categories. If you want to add more, you're more than welcome to. Notice that miscellaneous is here in both categories. Now, what's going to determine that is the actual transaction type, which we'll talk about later on, whether miscellaneous is a debit or a credit. But there are 19 credits and there are 15 debits, but because miscellaneous is used twice, we're only going to use it one time in our category type, which you'll see here shortly. So that means we'll have 33 categories rather than 34. So we're not going to repeat miscellaneous more than once. Note, list miscellaneous only once in category, and I indicate that here in the requirements. However, all transactions should record whether the transaction was a credit, income, or debit expense, and from which category the credit or debit came. That means that when we do a difference of credits and debits, we can actually find out if we're in the red or if we're in the black, or how we can modify our family or individual budget accordingly. Business rules. A financial institution provides many types of accounts, and many types of accounts are available at many institutions. Gang, I always tell you to make sure that you always start off with pencil and paper. It's the fastest way to start off developing, rather than going to a case tool or an IDE, that is an integrated development environment, or a case tool, computer assisted software engineering, or sometimes also called computer assisted systems engineering. Always do a paper and pencil, and that way the more you use it, the more comfortable you become with it, faster and more efficient you are or will be. And then you could also use it with your boss, your client, or even yourself when you're trying to create a solution, whether it's a software solution or a database solution or a network solution, etc. Get comfortable with pen and paper or pencil and paper. Financial institution provides many types of accounts. Many types of accounts are available at many financial institutions. We know from our discussion in class that that is a many-to-many relationship. Remember, when we do a many-to-many relationship, that we don't have to worry about, and I'll go back and forth here. I'm going to show the solution, but also give a little bit more detail as far as why we made the decisions that we made. A financial institution provides many types of accounts. Many types of accounts are available at many financial institutions. I've said more than a few times, there's institution, there's account, that number one, we always keep our tables lowercase. Here it's entities. We all keep our entity names lowercase, and make sure that we prefix each attribute with a suitable 3-character prefix of the table name. Now, if we have a really large database, 50, 100, 200, 500 tables, we may have to go to 4 and 5-character prefixes, but still it's going to make your development a lot easier to maintain, particularly when you get into the SQL programming, because you'll know by the 3, 4, or 5-character prefix and the underscore what table that you're actually writing in your program, rather than having the same named attributes in all of your tables. For instance, here we have institution, street, city, state. Well, for a user, we could have just street, city, state, institution, street, city, state. When you're in your SQL program, or I should say when you're in your SQL exercises, you'll have to fully qualify those attributes because the compiler, or I should say the SQL interpreter, will be not understand which attribute you're referring to. So it'll give you an ambiguous error. It's a lot easier to come up with a really good, solid model to begin with. All right, so we know there's a many-to-many relationship here between institution and account. As I've told you many times in class, just throw something in the middle of that. Throw something in the middle. We came up here with a name of source, but you could call it whatever you want. You could call it hamburgers if you wanted to, or hamburgers singular. But the point is not the name. The point is the resolution to the many-to-many design issue. So we'll talk more about that in a little bit. And also, when we have a many-to-many relationship, remember that we have a solution to that relationship, that the solution, the many side, always points to the solution, or the resolving entity. So here we would have an institution one-to-many, then account one-to-many, or many-to-many, I should say, and you'll have the many-to-many relationship here, but that's not what we want. You can't implement that. So we're going to have our one-to-many, and that would be two one-to-many relationships. The resolving entity always gets the many side. Okay? Let's move on. Many accounts can be associated with many users, and many users can have many accounts, but must have at least one. Now, if you were doing this in pencil and paper, you'd probably make another entity here somewhere. Hopefully you can see my cursor here that's being recorded, where it says here where I have notes. Each user can make many transactions. You'd probably put an entity here. And by the way, this is just my method of developing. I'll take the design and I'll put all my notes inside of the ERD. That way I don't have to keep going back and forth to the actual business requirements. I'll put them in here, and that also is another way of referring to it with your client or your boss. Just have it in the ERD. But anyway, you probably put another entity here between account and user, maybe not realizing that you already have this source entity. Even if you don't have a name for it, you can use this for multifarious solutions. In other words, resolving the many-to-many relationship between institution and account, and resolving the many-to-many relationship between user and account. By the way, there's also an implicit many-to-many relationship between institution and user. Makes sense? An institution can be associated with many users, and a user can be associated with many institutions. This source entity contains a lot of data. For instance, the source ID contains, each source ID, I should say, contains the user, the institution, and the account to which it's referring to. Also, the start date and the end date, if there is an end date for that particular source. So realize that the source entity contains data for institution, account, and user. So far we resolved these four business rules. Let's move on. Many transactions are processed from many accounts. However, each transaction is processed from a specific account. Okay? Well, again, we could make another many-to-many relationship between, or I should say not a many-to-many, but a one-to-many relationship between account and transaction. Essentially, it would be a many-to-many relationship, right? If we wanted to make it as per the second part of that business rule, many transactions are processed from many accounts. However, each transaction is processed from a specific account. One could also say that a transaction can be associated with many accounts. An account can be associated with many transactions. There lies too another many-to-many relationship. And again, we have this source entity that resolves that. And we resolve it by this. A transaction, or many transactions, are processed from many accounts. Here we can have as many accounts as we want. So a transaction, or many transactions, are processed from many accounts. However, each transaction is processed from a specific account. And that resolves not only the many-to-many relationship here between transaction and accounts, but it also indicates that we have here a source, which includes a user, institution, and an account, will be associated with many transactions, but each of these transactions is actually associated with one and only one source. One user, one institution, and one account, and can make many of those transactions, but each one is associated with one user, one institution, and one account. Becomes a foreign key in the transaction table. All right, moving on. Many users make many transactions, and there is our many-to-many issue there. Let's take all four of these in total here. Many transactions are processed from many accounts. However, each transaction is processed from a specific account. Many users make many transactions. However, each transaction is processed by only one user. And again, you have that many-to-many relationship between transaction and accounts, but it is resolved with this resolving entity and still satisfy the requirement that each transaction is processed by a specific account. You could extend that to each transaction is processed by a specific institution and a specific user as well too. All right, a budget. Category is used in many transactions. However, each transaction can only use one budget category. Here we have that. Category is used in many transactions. However, each transaction can only be used or include, you should say, one category. Now, if you wanted to extend that, which we're not doing in this particular exercise, which, by the way, I hope you use this model. It's not just for academic purposes or didactic purposes, but I hope you actually use this for your own budget or your own family's budget. I think it'd be very useful for you. If you wanted to extend that, you could actually make, if you wanted to include more than one category in transaction, you could actually make a many-to-many resolving entity between category and transaction if you wanted to do that. We're not going to extend it that far in this particular exercise, or I should say assignment, but you could if you wanted to. Okay, next, accounts. Note, accounts include savings, checking, mortgage, loans, investment, for example, CDs, 401ks. This really should be lines of credit, or you want to say some type of credit. Maybe, again, a line of credit would be one example. Cards, credit cards, debit cards, if you wanted to, would be part of the accounts. Note, always refer to the assignment guidelines. Say notes for regular attributes that must be included, additional attributes not including PKs and FKs. Meaning that a regular entity like institution would get name, street, city, state, zip, phone, email, etc. But also would include a URL, right? All banks would have a URL, right? All financial institutions would have a URL. We'll talk about contact here in a minute and why we include that. User, same thing. A regular entity, so F name, L name, street, city, state, zip, phone, email, and the associated data types for each. Remember, we're going to have all of our numeric values are going to be unsigned because we're not going to store negative values. If, in fact, you ever decided to store negative values, not calculate them on the fly, but store them, then you would need to make those data types signed rather than unsigned. So here, category and account will include an ID and type, and category types are listed above. Here we got our categories. I'll show you real quickly how to include those. So category and account will include ID, type, and of course all of our entities includes notes, right? Why do we include notes? Because it will save us from having to alter our database design, right? It'll save us from having to do that. Where do we put in our user account here that say the particular user, even if it's a family member, has accumulated many different overcharges, right? There's no attribute for that, and you don't want to make another attribute called overcharge yes or no. So you just include this user notes, activity, or I should say account notes, institution notes, and that will save you in the long run because it can include any type of data that is not specific to a particular attribute. Account and category are the easiest ones. They both include an ID. By the way, all primary keys are auto increment. PK, not null. Unsigned auto increment. Make sure you have that. We're going to go into the attributes here shortly. Source is going to include a start date and end date. Not just start date and end date. Remember, source is a resolving entity for actually 3 different entities: institution, account, and user. So source is going to have its own primary key. It's going to have the foreign keys of user, institution, and account. So those have to go in there. But the other 2 attributes are start date and end date. Notice that end date can be null because we don't know when that source's end date will be. So it can be null. And of course, notes is always null, right? Unless you come up with a design where you're always going to use notes all the time. And you may, but for our designs, we always use notes that can be null. Transaction. Transaction is going to include, other than a primary key and foreign key, the type, the method. The type meaning whether it's either debit or credit. The method meaning whether it's going to be the ATM. What type of transaction is it going to be? ATM, point of sale, POS. A check number. Is it going to be a transfer from one account to another? Is it going to be bank, etc.? Now, when I say bank, I mean that the transaction actually occurred when you walked into the bank. If you want to have some other type of transaction that's specific for your budget needs, feel free to put that in there. The transaction amount and the date. Now, the date's going to be a date time, right? Just like you would go to an ATM. And that ATM records, well, not only the place, but the date time when that occurred. We're not worried about the actual location here. We're just worried about the date time that transaction occurred. Okay, and of course the following criteria are required for the ERD, which we've been doing since day 1. Entities include color, connectivities, relationship strengths, use-appropriate drawings of lines between entities, relationship participations, whether they're optional or mandatory, primary keys, foreign keys, PFs. Remember, PFs is that special dual relationship, which we don't have here, but that an attribute, say in a specialization hierarchy using inheritance, that the subtype would actually function, the primary key of the subtype would actually have dual functionality. It would have the functionality of a primary key as well as the functionality of a foreign key. But we're not using them in this design. Suitable attributes: first name, last name, address, phone, etc. We talked about that. And relationships between entities. That is the use of verbs in the ERD. Remember, gang, once you can get the business rules down, and I've said this more than a few times in class, if it comes in a long narrative, verbose narrative format like from your boss or a client, and you have several pages of requirements, break down those business rules into bulleted points. It's going to be much easier for you to discuss these bulleted point requirements with your boss or client, whomever, than it would be a paragraph. So break them down, and as I mentioned to you on a number of occasions, always, once you do that, always confirm with an email, because an email can be used in a court of law. You don't want somebody to stiff you with these requirements. In other words, they're not going to pay you for the extra time that you're putting in, and pretty much all projects get scope creep. So you're doing such a good job, and the client or your boss wants you to do more work, and that's fine. Maybe you're on salary and you have to do that, but at the very least, make sure that your boss acknowledges the agreement in those business rules as they exist. And particularly with a paying client, make sure that they email you back, yes or no, that this is the agreed upon set of business rules. Also, for this assignment, we'll be doing the SQL statements. We'll be doing those in class. I have a helper video here as well too on how you could do number 6, create an Excel file with 10 records in the transaction table. You'll notice that the transaction table is the only table that we use in this design that does not have data at the point of the model. In other words, right here, when we forward engineer it, there's going to be no records here. And I want you to know how to upload records from a comma delimited file, otherwise known as a CSV. CSV actually stands for comma separated values. So here's a YouTube video that I created that will help you with that. So we'll do 1 through 5 in class, and 6 is on your own. I have all the information here to make you successful just by looking at this, watching this video. Okay, let's go back to the requirements here, and now let's look at the ERD. Okay, and see how we modeled this. Okay, institution and user, again, pretty straightforward. Let me show you some of the attributes, their data types, as well as some of the data here. So, for one, here's all my attributes. Now, gang, remember, let me make this a little bit smaller here so that you can see all the attributes and their data types. I think that should cover it, right? Shoot, a little bit less here. And right there. Okay. Notice that all the attributes are required except institution contact, which is a varchar 45, and institution notes. What is institution contact, or INS contact? And I put here in the comments, it's a person's full name. Now notice I never ever have you do a person's full name or do what we call a composite attribute that would contain more than one datum. Notice we don't do, well, here's the institution, so yeah, we're going to put institution name, right? Region, SunTrust, Bank of America, whatever. But we wouldn't put person or user name. We do user F name, user L name, and even user initial, middle initial, or user middle name. Because what we want to do is be able to sort and search based upon that data. It makes it much easier to do that. And we could always format the report any way we want to, but we don't want to conflate our data by having a what's known as a composite attribute. I have you do this in this particular design. Notice that I always have you do something that you're building your skills upon prior models or prior business rules that we've worked on. I'm having you do a person's full name here because we're not really worried about the person's full name. Let me give you an example here. We're worried about the institution. Now, you may have a bank that you bank with, or say an outstanding loan or something like that, an institution you have a loan with, school loan, whatever. And then here, what you could do is put that person's full name as a contact. Let's take a look at some of the data here. So here I got, as an example, let me make this a little bit wider. As an example here, I got Bob Flounder. Of course, these are all made-up names here. But the full name, because we're not going to do sorting and searching, this is not going to be a multi-million record database, right? Even if it's used for your own personal purposes, I'd venture to say that you're not going to be involved with more than 100 institutions. Okay, if you are, you may want to think about redesigning the database, right? But this would suffice for actually a pretty good size budget database. And that's why I just have you here. And the other thing is, we're generally not going to have more than one contact at an institution. If, in fact, you did, all you would do is have to put them in the notes section. Again, the notes is going to prevent you from having to redesign your tables and ultimately redesign your database. You won't have to do that because notes and all tables is really a catch-all. Notice how the data is here, gang. No hyphens in zip codes, any zip code. No hyphens or parentheses in phone, because we don't use that. We make our data as clean and as efficient as possible. remember that our institution zip, or I'm sorry, institution state is going to be 2 characters, char2. A couple of you have been putting more than 2 characters, and then you get an engineering error, something to the effect of, well, I'll just demonstrate it right now. I'll put in here Georgia instead of GA, okay, Georgia, and don't forget to hit your green check mark anytime you modify the data. I'm going to go through the process of foreign engineering this, and make sure you have your 4 checkboxes checked here. Generate insert statements, drop objects before each create object, generate drop schema, and add show warnings after every DDL statement. Click next. Only have one box checked, and that is export MySQL table objects, only that one. You can look at this SQL statements, or I should say the SQL if you want to. They are SQL statements. Make sure it's not MyDB, gang. MyDB, I still see a few of you that forgot to change their database name. By default, when you open up a new MySQL Workbench file, or model I should say, the default is MyDB. We have to change that here in the catalog tree, right here to the left. Just go right click on that and change it to your FSU ID. And it should reflect, when you forward engineer it, that should be your FSU ID, not MyDB. Okay, go next, and you'll see that I get an error. And there it is. It says here, data too long for column institution ID at row 1. So we go back and we just fix that. So if you get that error, try to read your errors, try to figure it out. If you get stuck, just post it to the DB or email me. Now I made a modification here. Click the green check mark and fix that. Let's look at our columns again. So here's all the data for institution. Okay, you don't have to use mine. You could use yours. Let me make sure you're seeing all the data here. So you're seeing how that data is represented. Again, you don't have to use mine. You could use yours. Feel free to do that. Gang, sometimes you get an error that you haven't, and the error is something like this, that by accident you included another record. So make sure that you don't do that. Make sure you don't include another record here. If you do, it'll indicate that you have another record. Notice I don't have another record here, but I notice it's a little bit easier to do that on Macs than Windows. But you'll see that if you do have another record, just right-click on that row, click on the row, then right-click it, and then you could delete that record. Then click your green check mark and make sure you don't have any extra records that you don't need. Okay? That's all my data here for the institution table. And then go to columns just to make sure you see that. Institution ID, gang, remember, you don't have to select these attributes either. I'm just using them as an example, but for institution ID, I don't anticipate having more than 255 institutions. So I'm going to make it PK, not null, unsigned, auto increment. Remember, all our primary keys are auto increment. Don't forget that, because if you do forget that and you have null here, and always do that. Let the database do the heavy lifting for you. Don't insert the data. Sure, it's easy for 5 records or 10 records, but it gets a little bit laborious when you have 10,494 records. What's the next record number that we need? Then you have to go scroll down or do a select all or limit one, order by, say institution ID, descending. You don't want to have to do all that, right? Let the DBMS do the heavy lifting for you. Make it auto increment. The database will automatically track the next record. So we don't insert a value here. By the way, if you do, by chance, if you do insert a value, all you need to do is click on that. So click on the record. Here I am, institution ID, set to null, and then you're not going to see the change, but just hit your enter key and you'll see that it goes back to null. You can't type in null, you have to set it to null. Okay? And that is by right clicking on it and just set to null. Columns, tiny int. Notice all of our numeric values are unsigned. Institution name, varchar 30, street, varchar 30, state, city 30, state, char2, int zip, big int, phone, varchar 100 for email and varchar URL 100 for URL. Notice that for contact, not anticipating a name more than 45 characters, even if it was a first and last name. If you anticipate that, you can make it larger, but just took the default on that. Notice I put that in the comments too. So I clicked on institution contact and I said, okay, what's institution contact for? Well, MySQL Workbench, you could put that in the context what each one of these columns represent. And by the way, this translates into the SQL. Remember I demonstrated how you could put comments for each attribute in your SQL statements as well too? All right, let's go to the next one that makes sense, and that's user, because user is going to be very similar to institution. So everything's the same here. Unsigned. Notice the user ID. Again, I'm not anticipating for the small budget database we're using. I don't anticipate more than 255 users. So PK, not null, unsigned, auto increment. Here's all your attributes here. You could take a look at that on your own. Pause the video. Let's look at. We already looked at account, but let's look at an account again. For user, again, I want to show you the inserts here. There's all my inserts. You could use these if you want to, or just use your own. Be careful with the zip code and phone number. Remember, it's only numbers, and no negative numbers either. Phone numbers don't have negative numbers, so only numbers, and make sure there's no hyphens or extraneous or superfluous characters. Let's go to account. Account only has 3 attributes. Again, tiny int. I don't anticipate more than 255 accounts in this family or individual budget database. So PK, not null, unsigned, auto increment. Account type, varchar 20, not null. And then account notes, of course, can be null. What values did I put? Well, here's my inserts. Where did I get those? Well, if you don't know what type of accounts you can have, I gave you some ideas right here, right? You could use those, or you can go online, do an internet search on financial institution accounts and put some in there, or put some in that you have of your own. That's fine. To do that, I just included 5 here. Remember that each table needs 5 records. So checking, savings, mortgage, school loan, and investment. Okay? Let's go to source. Let's take a look at source here. Notice source is a resolving entity. It resolves the relationship between institution, user, and account. Resolves 3 separate many-to-many relationships between institution and account, between user and account, and between institution and user. Resolves one entity, resolves all 3 of those many-to-many relationships. Now, be very, very careful. Notice in the source that the foreign keys must match the value of the primary keys in the parent tables, not only in values, but in data types as well too. Since I made my user ID, institution ID, and account ID all tiny int, unsigned, and not null, of course, then these foreign keys are going to be not null. The reason why these are not null here, it's not because the primary keys are not null. Primary key by definition cannot be null. But the reason why here is we're saying that the source must include, to be a source, it must include an institution, it must include a user, and it must include an account. Okay? What else do we need? We need a start date and end date. What data type is that? Just date. Okay? Just date. And we're saying that the source ID, because who knows, we may have a number of institutions and a number of users and a number of accounts, and we may go past our 255 record limit for tiny ints. So what's the next integer size up? It's small int. And a small int will cover our next data type. It only stores 2 bytes of storage space, and that will allow us an unsigned, first of all, a signed small int, meaning if we left it like this, could handle values from negative 32,768 to a positive 32,767. But that's not what we want. Our primary keys are never going to be unsigned. Now, again, there may be some anomalies for whatever reason, but I promise you, they're going to be extremely rare anomalies, extremely rare when you'll have a primary key to be negative. And please don't email me 10 years from now and say, Dr. Jewett, I had primary key was negative. Yeah, what? One database design in your entire professional career? Anyway, if that's the case, just make it make it signed like that. But if we make it unsigned, then now we just increased. We doubled the values that we can include in our primary key. Now, an unsigned small int can hold the values from 0 to 65,535. Okay, we got that. Let's look at some of the inserts. Okay, and remember, we have users 1 through 5, we have institutions 1 through 5, and we have account IDs 1 through 5. But you don't have to use all those values 1 through 5. But what you do have to do is follow the second rule of database design. First rule is, you all know that, that's the easy one. All tables must have a primary key, and a primary key cannot be null by definition. And by definition, the primary key, because it is a primary key, must be unique. Not so with the foreign key. The foreign key, second rule of database design, is that the foreign key must match the value of the primary key in the parent table. So if I have values 1 through 5 for user, values 1 through 5 for institution, values 1 through 5 for account, those are the only values that I can use. But it doesn't mean that I have to use all of them. I could have here 1, 1, 1, 1, 1. So all of these could be 1. And then 1, 1, 1, 1, 2, or actually 1, 1, 1, 1, 1. So both of these could be, for I have 5 records right now. User ID and institution ID. I could have 1s across the board. And then I could do, again, 1, 1, 1, 1, except for the last one here for account ID. I'm sorry, my apologies. Except for these 3 right here, right? Because if I have 1, 1, 1 for all of these, I can only have this record be 1, 1, 1. Because logically, you wouldn't want for a source to be the same user with the same institution and the same account more than one time, right? And when we say account ID, really what we mean is the actual account number, all right? Here we're making it simple because we're making an auto increment. How do we enforce that? We enforce that. Let's go through the data first. I'll show you how we enforce that. We talked about it before. We create a unique index. Notice the start dates, gang. I still see some of you putting in the wrong or incorrect way of doing a date in MySQL. The way that we do dates in MySQL must be like this, you guys. It must be like this. And that is 4-digit year hyphen 2-digit month hyphen. So 4-digit year hyphen 2-digit month hyphen 2-digit day. You must include your MySQL data types like your MySQL date like that. Now, if it was a date time, what we would do is space like this: hours, hours, colon, minutes, minutes, colon, and seconds, seconds. Notice if we had a date time, there has to be that space between the D's and the H's in our date time data type. But here we're only using the date. We're not having hours, minutes, and seconds. Okay? So that's why I have the date like that. How do we enforce to make sure that we don't have spurious data here? The foreign key, the primary key is not enforcing that. The primary key can be unique all day long. All day long. But what we don't want to do is have the same user with the same from the same institution and the same account be entered more than one time like this, which I'm showing you right now. We're going to get an error. And I'm going to show you how we enforce that. Forward engineer this. Okay. Notice the 4 checkboxes that are checked. You can pause that. Again, make sure that only this checkbox is checked. Export MySQL table objects. Make sure again you have the correct database. You could take a look at this if you want. You could also copy to clipboard the SQL and then paste it into your favorite text editor to look at all the SQL. Go to next, and then you'll see that we will generate an error here, and then I'll show you what that error is. It says duplicate entry for key UX user INS ACT. Duplicate entry 111. Well, how do we get that duplicate entry? I'm going to put a 2 back in here in case I forget, and click the green check mark. Make sure I save that data and go to indexes. Now, to enforce this data, our constraint here that not more than a user at a particular institution with an account cannot be used more than one time. To enforce that, we go to the tab here called indexes. I'm going to open this up a little bit for you here. First thing we want to do is create a name for that index. Now, again, you can call it whatever you want to. You can call it X if you want to, but you always want to make sure that you have your naming convention, something that makes sense, right? Just like your attribute names, INS underscore ID. Okay, I know I'm using the 3-character prefix of a table followed by the ID, right? INS underscore name, or for a customer, CUS underscore F name, CUS underscore L name. It doesn't have to be long, but something that's intuitive. Here we're saying we're creating a unique index. So to create that unique index, we want to give it a name. Again, the name, it doesn't matter. Call whatever you want to, but to make it something that's intuitive, I use the convention of prefixing the unique index name with the characters UX, right? Standing for unique index. And then what I do is I give the name of all the attributes that I'm going to be using in this unique index. And here, and if you wanted to, you could do this as well too, user underscore ID, right? Underscore INS underscore ID underscore ACT, the actual names of those. But it's a little bit, you could do that if you want to. It just appears to me that this is rather intuitive right here, right? So all I'm doing is just using the names of the attributes followed by an underscore. But without the actual name, I'm really indicating the tables that are being used here: user, institution, and account. Okay. The next thing you want to do is make sure you select the drop-down menu, unique. Okay, just go here, select this drop-down menu, make sure it's unique. By the way, by default, primary keys automatically have a unique index. And also in MySQL, when you create your foreign key relationships, guess what? MySQL automatically creates indexes for all your foreign keys. So I have foreign keys here that I did not create. But if you're doing SQL, you would have to create those on your own. Anyway, here's the name of that unique index. I make sure that it's unique, selecting the unique option here. And then, what are my attributes that I want to make sure that are unique in their totality? In other words, as a composite. So as a composite, I cannot use user ID, institution ID, and account ID more than one time. What is this? What are these numbers for? One is how they will be indexed. What is the most important index when it's in a SQL statement and you're trying to do a SQL statement for as a select statement, that is, for a where clause or an order by clause? Am I going to order by or use a where clause mostly for a user or an institution or an account ID? I would say that for me, I would probably do user first, and then account, and then institution. If you want to change that somehow, feel free to do so. The order by default is ascending. How are you going to sort, or how are you going to search? What is your order by clause going to be? Is it going to be ascending? Are you going to search for institutions in ascending order or descending order? You could change the sort order by just flipping that around to ascending to descending if you want to. By default it is ascending. Okay, that's how we enforce the unique index. Okay, if you have any questions about that, please post them to the discussion board, or if need be, send them to me in an email. So we got all 4 of these entities. We've talked about that. Let's talk about the next easiest one, category. Now, category is rather unique in the fact that it's going to include all 33 categories. So it's not 19 plus 15, but it's 19 plus 15 minus 1, because we don't want to use miscellaneous more than one time. So I'm going to show you how to easily do that. I'm going to put that into MySQL. I'm sorry. I'm going to put this into Emacs. And what you have to make sure, gang, is that, and matter of fact, to save time, I'm just going to show it to you from how I have it inserted into my category table. But what you would easily do is just copy and paste them like this. I would copy and paste those values like this. Make it a little bit larger so you could see. Okay. Take out this, don't need that. And then put enum, doesn't matter if it's lowercase or uppercase, enum, take out this as well too. Okay, take out miscellaneous, because I'm going to only use it once and I have it here, right? So I have that like that. But there's one other thing I have to do. I have to make sure that each one of these values are wrapped in single quotation marks. So I'm not there yet. What I have to do, and not to bore you with this, I'll show you. What I have to do is this, okay? Rather than taking time to do that, show you the correct enum. And that is this right here, okay? Make sure that each one of those enumerations or enum values has one single quotation marks wrapped around it, followed by a comma. Now you don't have to have a space here after the next one. It just makes it easier to read. But you do have to have the single quotation marks after each enumeration, followed by a comma. And make sure those quotation marks are inside of that those commas. Okay? So make sure each one has that, including miscellaneous. And we don't need a period there for miscellaneous. Okay? So this is your solution right here for the enumeration. Okay? All right. Category ID, of course, is going to be a tiny int, PK, not null, unsigned, auto increment. There's all our category types here. A couple things, gang. How many category types do we have? 33. But, as I mentioned to you, each one of our tables only needs 5 records. So why are we creating enumerations? The reason why we're creating an enumerator here is so that it prevents us from adding data. It's a second, well, it's an initial layer of security here, depending upon whether it's a web application or not. Your initial layer of security is actually at the client side, right? Doing JavaScript data validation or some type of data client-side validation, then server-side validation. But ultimately, it's going to go to the database validation as well too. So we created 33 enumerators here, or I should say enumeration values, but we only use 5 of them. But it prevents us from actually using data. And by the way, this is case insensitive, so it could be spelled uppercase, lowercase, mixed case, it doesn't matter. But I cannot include like housings, right? Because we don't have an enumeration for housings, enumeration value. We have housing. We don't have foods. We have food. So it prevents the user from, on purpose or by accident, putting in data that doesn't belong to that database. Another method, by the way, gang, if you take my web application development courses, is always your first layer of defense is your client side. however that user enters the data. And when we do web applications, it's the browser. So make sure that you use drop-down menus and radio boxes and checkboxes whenever you can, because it prevents a user from actually typing something in incorrectly. Also, use for web applications, use placeholders or some type of notation to indicate to the user what data type is expected. That way, you prevent them from annoying them, number one, because they may put the incorrect data type in there by accident, and then they have to go through the process again. So just indicate that with a placeholder or some notation to the side of the control or above it somehow to indicate what data type is expected. Let's go to transaction. Now, transaction is really the culmination of all our tables, right? The meat of our database here is all these transactions from where we could draw reports from. What type of transaction it was, where it was from, who did it, how much was it, is the family member in the black and the red. We could extend this to larger databases as well too. It doesn't have to be a family member, it could be an organization. We'd probably have to change some of the data types to a bigger integer value instead of tiny int, maybe a small int or even more. But let's take a look at the transaction and the attributes. The transaction, I'm going to make this a little bit larger here so you can see all of the attributes and their data types. So tran ID is medium int, pk not null unsigned auto increment. By the way, just FYI, we can use medium int in MySQL, but we cannot use medium int in SQL Server, as you'll find out. So we cannot use medium ints in SQL Server. If you're going to try to make your designs portable, be cognizant of that. Here I have you use a medium int to show you that there is a medium int in MySQL implementation. It allows for that data type. Source ID, well, source ID has to match the data type of the source, and that is small int. So our foreign key must match small int, and it must be unsigned, right? Because all of our numeric values are unsigned. Category ID, tiny int, we see that. It's unsigned as well too. Gang, be careful. It has to be unsigned. So the category ID is tiny and unsigned. And now the tran type is another enumeration, but only has two values, and that is credit and debit. And again, remember how to put those enumeration values inside of an enumerator. And that is, the enumeration is wrapped, first of all, in parentheses, and then each enumeration value is wrapped in single quotation marks. By the way, it could be double quotation marks as well too. Single quotation marks just makes, I think it makes it a lot cleaner to work. And then each value then is separated by a comma. So it's going to look like this. Okay, just enum, credit wrapped in single quotation marks, comma, debit wrapped in single quotation marks, and then parentheses around both of those values. Okay? All right. Tran method. Varchar 15, I'll show you the data so you can see that. Now, I even put in the comments what we're going to use for a tran method, or I should say the data type for that. And that's going to be, for example, an ATM, POS, check number, whether it's a transfer, whether it's a bank, etc. In another video, in the video that I indicate here in the project requirements, in this video, I show you exactly what those data values are. Right now, we don't have any data in here. Okay, we don't have any data in here. Tran amount is going to be decimal 7,2, meaning that if you ever forget, all you have to do is the left argument is a total number of digits, 1, 2, 3, 4, 5, 6, 7, and then the right argument is how many digits to the right of the decimal point. All we have to do after that is add 9s instead, so 1, 2, 3, 4, 5, dot 99, and we could see that the largest value we can have here is 99,999. Be careful. I put 1,000 separator in here. By the way, that should be a period. The only legitimate value other than a number when you're using numbers is a period. You cannot include commas. I just put a comma in here to make it easier to read. But you cannot include commas in your data values. They must be without commas. Okay? So that's that, gang. And I'll open this up to show you the inserts, but you'll see there are none. There are no inserts in here. The next video will show you, in fact, how to forward engineer this. Well, actually, I'll forward engineer it right now. But after it's forward engineered, how to get data inside the transaction table. Okay, so just to show you that this works, I hope it does work, because I think I may have made some changes here. We'll see if it works or not. But if not, we'll correct the errors real quickly and then get it to work. And let's see if it works. I know you guys are hoping it doesn't work, but evidently it did work. So we got lucky this time. Okay? All right, gang. If you have any questions, please post those to the discussion board or send me an email. See you all in class.